Okay, folks, I did not get to record during class today. The other video from academic was still downloading, and I decided I have enough time during my conference period so that the folks who are not here today, I want to go ahead and try to get them a video as well. So we've been talking about normal distribution. Okay, it says in general, to designate that a set of data is normally distributed, we use the notation. So the symbol here, you might recognize it as similarity in mathematics, but here, the way this is written, we're going to say that x is normally distributed. Now, it looks to be what an ordered pair. The first value is mu, the mean of the data. The second one is the variance. You remember we use the lowercase sigma to represent standard deviation, but when you square it, you have the variance. So really, you just want to basically ignore the power because we want the standard deviation. So an example says, if x is normally distributed with a mean of 10 and a standard deviation of 2.3, find the following probabilities. Okay, so this is just what we did the other day, where we are going to go into the calculator. Let me pull this up very quickly. So from your scratch pad, you're going to go to menu. We want statistics, distributions, normal CDF. We don't want normal PDF. Normal CDF with normal distribution. Now, if we're looking at our value here, we want the probability of it occurring between 8 and 11. And you'll notice here we have both a lower and an upper. So I'm going to go ahead and put both of those in. So we want this between 8 and 11. My mean was 10, and the standard deviation was 2.3. So I click OK, and I'd say we're about 47.6% probability of choosing a value between that. Okay, well, let's take a look at the next one. We want the probability of choosing an element less than or equal to 12. So because we're less than, this means that 12 is an upper boundary. Okay, so I'm going to go back to my calculator, menu, statistics, distributions, normal CDF. Now, because 12 is my upper, we don't have a lower, we're going to leave this lower right here. Remember, the E is scientific notation, so this is an incredibly small number. I'm still going to go ahead and put in my mean and my standard deviation. So what's the probability of choosing an element less than or equal to 12? Well, I'd say it's about 80.8%. Okay. All right, let's try one more here. Now this one, the probability of choosing an element greater than 9. Now you'll notice these have equality, this one does not. Equality doesn't matter here with what we're doing. It simply matters if it's less than, this becomes an upper. If it's greater than, then 9 becomes a lower. All right, so let's go ahead and put in the information. So once again, menu, statistics, distributions, normal CDF. So this time we have a lower boundary because we want everything bigger than 9. Now, if it's simply greater than or equal to, that does not matter. If you have no upper boundary, you just want to fill the upper bound with a bunch of 9s. I know it sounds silly, but that's what we have to do. We got to put in those boundaries or it's going to give me an error message. I put in my mean and my standard deviation. So the probability, I'd say, is about 66.8% for that happening. Okay, good. All right, if you have any questions, please come in and talk to me. Now, this problem right here, it says, given the following set of test scores, determine if they are approximately normally distributed. You're going to be told that data is already normally distributed. IB is not going to have you look into that. Okay. Now, I'm going to go ahead and allow you to read this. You can pause the video or look at your notes, but I want to go ahead and look at these last examples. It says to calculate the quantile using the calculator, we must always be looking for the probability of an element less than k, not the probability of x greater than k. So you're going to see there's a difference here in these types of problems and these problems. See here, we're already given a range, like an upper and a lower to deal with. We're trying to find the percentage, right? Well, here you're working backwards. We're already given the percentage. Okay, so if I were to look at this on a normally distributed bell curve, it would look something like this. Okay, here's my normal curve. Right here in the middle, there's my mean of 12.4. We've got a standard deviation of 1.3. Remember, ignore the square because the square gives you the variance. Okay, so think about it. We're looking for some value k where less than that number would represent 75% of your data. So think, where would k have to go in your diagram? Well, it would have to go over here on the right someplace because you're actually trying to find an element of your data. So all the data leading up to the one that we're about to find, well, that would represent 75% of the data. Okay, well, let's go ahead and see how to do this. All the steps are the same. I'm going to go to menu. I still want statistics. I still want distributions. But now, okay, we're no longer trying to find the percentage. Okay, we're using the percentage to find the element. So we want inverse normal. I'm going to choose inverse normal. And now it wants the area. So we're going to plug in the 0.75. My mean, let me get to my paper here. I believe it was 12.4. Okay, and then my standard deviation was a 1.3. Okay, so I'm going to click on it. So I would say the element is about 13.3. Okay, there we go. So whatever the set of data looks like that gave me this information, okay, the element 13.3, everything that comes before it, that represents 75% of the data. All right, let's go ahead and do another one. Now this one here, you'll notice is different, and that's what this little statement up here was talking about. The calculator is only capable of doing less than k when it comes to these inverse calculations. So think of it this way. Let's look at it on a grid, not a grid, but a normally distributed curve again. So here we go. Here's my 12.4. Okay, we have the standard deviation still of 1.3. Now, we're trying to find the value of k where every element after it represents 92% of the whole set. So k would probably have to go right about here. Okay, because that would represent your 92%. But we just said when dealing with this inverse operation, the calculator is only capable of doing less than. So what we're going to have to do is say the probability of x less than k is equal to, well, if being greater than k is 92%, being less than k, well, that would be 8%, or 0.08. I shouldn't put the percent after the decimal there. Okay, so 0.08, so 8%. All right. So even though I'm going to be putting in this value here, I'm still finding the same element in the set. So this is all you have to do. When you're given the percent and you need to work backwards, if it's greater than, you need to take 1, which represents 100%, and subtract what you're given. So that's where I got the 0.08. Everything else is going to remain the same. I'm going to go to menu again. Let me go to my calculator. Okay, so let me clear this off because it's getting kind of full. So I'm going to go to menu, statistics, distributions, inverse normal. So we want 0.08. We had a mean of 12.4 and a standard deviation of 1.3. Okay, so I'd say we're looking for an element 10.6. Okay, all right, good. Let's look at one more question. A university professor determines that 80% of this year's history candidates should pass the final examination. The examination results were approximately normally distributed with a mean of 62 and a standard deviation of 12. Find the lowest score necessary to pass the exam. So you have to think, okay, let's look at this on a normal distribution curve. Looks like this. Okay, so right here in the middle, I've got my mean of 62. And then if I can draw a straight line, that would be great. You know, we typically go within 3 standard deviations of it. So with the standard deviation being 12, so like for example, above it would be 74, and then right below it would be 60. So you continue to add and subtract 12 as you go up and below. So you have to think that along this horizontal axis, These represent all the scores. Okay. And it said that the university professor determines that 80% of this year's history candidates should pass the final examination. Remember, below this curve, you've got 99.7% of the data. If we're told that 80% of the students should pass, well, then we know right here, dap smack in the middle, that's 50%. So we got to go to the left. I don't know, I'm just going to go ahead and guesstimate right here. Let's say the value of K we're looking for is right here, because if K represents the score that's passing, then anyone who scored after that would represent the 80% that we're talking about. Okay, well, if I were to put it in the notation, I would say the probability of X greater than K is equal to 0.8, the 80%. Well, remember, when we're using the inverse operation here, the calculator is only capable of doing less than. So if it is greater than, we're going to rewrite it as less than, and we're going to take 1 and subtract the decimal we're given. So I'm going to set this equal to 0.2. And that makes sense, because if what's in red, okay, the slanted lines is 80%, then this right here would be the 20%. Okay, so let's go ahead and plug all of my information in. Let's see, back here on the calculator, I'm going to go to menu, and statistics, distributions, inverse normal. We know that we're looking for 20% because we can only do less than on the calculator with the inverse. Let's see, the standard deviation was 62, or excuse me, mean was 62 and the standard deviation was 12. So what is the passing score? About 51.9, so 52. Okay, well, I hope this helped. Thank you very much for hanging out with me for a few minutes. It did not take very long. If you have any questions, please come see me. Thank you so much. Have a great day.